These are some clarifications on SQL Lab 1, so it's kind of my fault. I think in the pandemic last year we had already done one of the confusing things in class, uh, so this lab hasn't been updated for that. A couple things really, but I'll explain it as we go. Um, so I think I will actually just. I'm debating right now whether I want to go through some of these steps or not. So I'm making the decision as we speak. I was going to, then I was not going to, but I think I'll go ahead and show some of this. So I can't. Can I move this window? Yeah. So if you look down at the bottom of my toolbar, I have that icon for. I can't. Yeah, I can't highlight it. There we go. For SQL Developer. So that's what we're going to click. Let me go ahead and click it to get started. And of course it opens up in a different window on mine because I don't have everything in one window here. But I'll pull it over when it's done. You'll see a progress bar. It says Oracle SQL Developer at the top. Initiating extensions. A little starting dialog. And then it opens up. So you'll see something like this. And I have more connections than you do because I got to have stuff for managing the couple of courses where we use this database. But it should look fairly similar. So you should have already done this for SQL Lab 0. And just while I'm mentioning that, at the bottom of this lab, I've deleted it in this. I think I'll upload this change document. It's not really critical that you update yours. Just be aware that this last thing that I'm scrolling down to that doesn't exist, it says required homework. You've already done that as SQL Lab 0. So there's a couple things. You know, last semester it would have been there anyway, even if they didn't go on the pandemic. You know, just to make sure students could work at home if they needed to outside of the lab. But for you guys, you have to work outside of the lab. So that's why I set up SQL Lab 0. I kind of wanted to make sure you could, ironically, be ready for this week after spring break. So I open up this up, and what you'll have are these connections. If it's all set up correctly with your username and password, you've tested that and you've connected, you should be able to just double click on it here. It'll open up a workspace for you under that account. So some other things I want to go through. Let's see, what was the next thing? So yeah, this is going through that initial stuff that we just did. And changing your password, you probably should have done that already, but if you haven't, maybe you should do that now. And then for part 4, number 4, creating tables on your own, this is all you need to do. Copy and paste each one of these separately, and I do have to check mine actually. Let me pause while I do that. Here's the thing: I probably already created these tables, and I can't remember if they have data in them or not. So I'm going to check that and then get back with you. All right, I'm just going to show you what I mean here. So if you copy, highlight, do this sort of thing. Highlight, Control C, as in Control Charlie. In other words, the letter C. Then Control Victor, Control V here, paste it, or however you copy and paste. You guys should know how to copy and paste at this point. You can just paste it into this window, and you can click on the run script button, or hit F5, and you'll see the error you'll get. Let me do it again without the error in there. I hit the eraser to erase that output. You see that I've already got this. I already used an existing object. If you haven't created yours yet, it should create the table. Let's take a look real quick. How can we know real quick whether we have data in there or not? There are other ways in Oracle, but for me, what was this, vendor? I think it was vendor, right? I just do the select star from table name, and I've already forgotten what it was. That's not what I wanted. Just make sure I've got the right name. Vendor, yeah. So select star from vendor will tell you if you have data. And I don't want to delete this data, so I don't want to undo it. So I'm not going to do it. But this is how you would except for the error message that I got because this table already exists. This statement, let me go back to this. This might answer some of your questions too. This statement here will create a table called vendor with these columns and a primary key of V code, but it will be empty. It won't have any data in it. So this is the DDL statement, data definition language. And I think I told in the other video, I was wrong about this. You don't have to commit this. Whenever you do DDL, it auto commits in Oracle. So if you'll notice, there's a commit keyword, commit semicolon. Use those for DML. So if you update or insert, that sort of thing, if you add new data records to a table, or update or delete, I think delete, yeah. These are DML, data manipulation language statements, not data. It's the difference between metadata and actual data, right? So create table is DDL, or data definition language, because you're creating the structure that will hold the data. This is not data itself. This is describing the container of a certain kinds of records, certain data, right? So you're going to have a vendor table, and inside that it's going to be a vendor code, which is an integer, and the name of the vendor. You know, it'll be like a company name in real life. And that is this. What this means is that when you input the data, it will assign a variable number of characters to hold the name of the vendor up to 35 limit. So varchar is different from char. Char will exactly always be 2 characters. And again, that makes sense because state postal codes are standardized, right? TN, VA, GA, AK, HIs, etc. So those are always 2. In the order, whatever order is, that's always 1 character apparently. You'd have to know what the data means for that one, and I don't remember. Phone number in this case is always 8, so I'm not sure why it's 8 and not instead of 10, but it's 8. I see. Okay, area code. Area code's 3. So these are always, and the reason why you have the difference is because these are slightly more computationally intensive than these. So if you know a precise number for characters, you should always use char. But if you're not sure, so this is a question between performance and space. If you do varchar, it'll take up less space in the end, in memory or the disk or wherever you're saving your data, right? But there's computational, a little bit more computation about determining how much space it's going to use, because it's going to vary. So literally, variable character length here. And integer is just a whole number, just a review on that. And this statement here, there's lots of different ways to do this. Actually, this is the simplest way. I like this example because it's the start with the simplest. What you're saying is that I'm going to define a primary key for this table, which is this column right here that I've already defined. So this should be, you can also like put it up here. There's different variations on this, but I like this one. So what you'll notice about also all these not null, this means that you cannot add a record to the vendor table without giving data for all of these. You have to specify some kind of data for everything in this table, including the primary key, because once you set a primary key, it's also not null by default. So none of these can be null. In other words, null again, it means no value. It's possible in a database to have a column in a record that doesn't have data. For example, you don't know the phone number yet, for example. So you just leave it blank. It's not really blank though, because blank is a value in a way. It's empty. And this, you're literally not giving a value when it's null. In this particular table, though, it's not allowed for it to be, where is it? The phone number. Yeah, the phone number and area code are not allowed to be null. You have to put some kind of phone number in. So this is like in real life, if you don't have a procedure in place to handle this, it'd be the case where, say you get a vendor, oh, we were using this vendor, but you don't know the phone number, and you want to go ahead and add them to the database because you got to do some work essential thing with the database to do the relationship with them. You're like, I'll get the phone number later. This is the case where you have dummy values like 99999-9, whatever, that for a phone number, instead of just leaving it no value. So that's a decision you need to make when you create the database, whether you want to, if you got a procedure in place to avoid dummy values, you really should have tried to discourage dummy values in your database through your database design, combined with the business rules and the business procedures that you're designing for. Anyway, that's a outside of SQL Lab 1, really. I mean, but these are things you need to be thinking about. Before you get to this statement, actually, before you get to this SQL statement, this DDL, data definition language create table statement, you should have done all that stuff in the planning where you do the ER diagram and the business rules and all that. That should have, this is kind of, in a way, actually, this is sort of the end result of all that, these SQL statements. This should crystallize all those plans you made. Anyway. So, and then you got the product table. You can see it's similar. You got a P code, which will be the primary key, right? So it's also not null. It just doesn't say it here. But the fact that it's a primary key makes it not null. And then all these other things are not null. And you can look, there is a data type for a date. So that's an Oracle data type. This is just a small whole number. This is saying up to 2 decimal places, I think. I'd have to review what the 8 and the 2 means. So, but yeah, an 8-digit number with 2 decimal places, I think. Let me verify that because I don't want to tell you the wrong thing. I mean, what else is it going to be? But it looks like I was right. So yeah, precision is the total number of digits, and the scale is the number of digits that rise a decimal point. So that's what this is. And you can look that up if you want. By the way, this is for the later part in the lab. People had some questions about this, and it is confusing. I'm glad somebody asked a question about it, so I can describe what's going on there. So anyway, back to this. And the one last thing here is the foreign key. This is how you do the foreign key in SQL. One way, anyway. Again, a lot of these things, there's various ways you do these constraints. Sometimes they're called alter table. There's all kinds of weird ways you can do this, but this is one style. So you've got the primary key, and then you have a foreign key, which is, you're saying that the V code in this table, so this column right here is this, references vendor. In this case, what it's saying is that the primary key of vendor, which is V code up here. So this V code is related to that V code, references that V code. And this is where your referential integrity comes in. Because if you have this statement in your data definition, when you create this table, you add this constraint, this foreign key. What that means is that you cannot add any record to this table that does not reference some V code that exists in this table already. So if you say vendor, if you like add a record to the product table and you say vendor code 12, for example, there must be a 12 in here first, or you cannot add it. Likewise, if you delete vendor 12, like there's a guy with 12 right here, you delete that record from this table, but it's referenced, 12 is referenced by any record at one or more records in this table, then you can't delete from vendor. And that kind of relates to something that happened with this lab. Okay. Person went out the front door instead of disturbing me. Great. I guess they heard me talking. I was about to have to pause. I was getting my fingers ready. Anyway, so yeah, vendor delete, referential integrity. That's where referential integrity comes in. So if you remember from the midterm, I hope. So going back to the ER diagram, this is the one side and this is the many side. So if you remember crow's foot, this is, the line comes out of here and it goes down here and there's a foot. So this is one to many. There will only be one vendor 12, V code 12 up here. 12 is just an example too. It's a random number I picked up. I say the VIN code is 12. But there could be many 12s here that reference this 12. So yeah, the thing that came up is like the job thing that I have to fix for you, the in-class thing that's later in this lab. I have that already, and I wanted to delete it and recreate it, but I couldn't because I couldn't delete it because it referenced the imp1 table. So I had to delete both, and I'll show you what I mean by that here in a minute. All right. So yeah, this is just talking about how you run those scripts. Then yeah. So open up this. Let me look. See, do I have it open here? Yeah, I do. So let's just look at it real quick. I forget where we use the demo tables. I'm not sure if we use them again actually, but they're good to like practice with. So this is what mine's got. So I've already created these probably. Let's just see what happens when I run it. I think, and you'll see you get errors when you already have these things created. But let's see, because I haven't tried to run this yet. I don't know, I guess. Does this have a drop table in it? Looks like it worked fine. Have I not done this? Have I not done this one? I'll start in line. Yeah, that's not a problem. Two rows selected. Oh, here it is. This is oh, it's got the drop tables in it. That's why. So what you'll see often for a script like this, and we'll go over this quickly. This is some like PLS, SQL. This is some Oracle stuff that has to do with the interface. So set echo on will, once you type in the command, it'll echo that command so you know what command you typed, and then it'll show you the output as well. So that's why you have the echo there, and you got this prompt that just gives you like an informative message. I think this will probably show you who's doing the script, you, in other words, and the date. I think we can look at that here in a second. But this is the key part I want to talk. These data definition language, these constructs, metadata, whatever, objects in your database, you'll often see this in these kinds of scripts, like you use for a class or something, or maybe also in your, I don't want to say in your business because it's not common. You would like drop a bunch of tables in a non-development space anyway, maybe not live anyway, maybe development. But anyway, what this does is it drops all these tables first, and it drops them in the right order. For example, if one of these things is, say, department, employee is in a department, notice you delete the employee first, drop the employee in first, that table, because that will drop all the foreign keys to this first. Then what I'm trying to say is if you reverse these two statements, it'll give you referential integrity complaints, and it won't let you do it. Anyway, so a common tactic for these kinds of scripts is it'll drop a bunch of tables again, and it recreates everything and inserts all the data. This is tedious if you don't already have it, right? So let's look and see what's happening. I'll highlight the main things and like ignore the little weird things. So the things that you need to know, really. So you drop all the tables first in the correct order to avoid referential integrity. A sequence is an advanced SQL concept that Oracle, I'm not going to get into it, but it's one way of doing an automatic primary key, but we'll ignore that for now. You don't have to know this yet. You can look it up if you are interested in want further research or whatever. And then you create tables. So these are just like the other ones we saw, where you see department number is not null, and these are actually nullable. You can leave these blank, it looks like. But then you set the primary key to be debno. And don't worry about the variation. Again, I told you there are different ways you can do this primary key thing, and this is a variety. You're actually naming the primary key here, and then designating. This is saying the primary key is this column, but this constraint has a name, an actual name. So you're saying the demo department primary key is debno. All right. Then you insert a few records into that table you just created. So department number 10, 20, 30, these are primary keys, and these are the names of the departments. And again, you could like have a 50 and leave this blank. Okay, so when you create another table, and you can see this is where, again, this is the foreign key stuff. It does a slightly different variety of syntax from what we had before. But again, it's a foreign key way. It's referencing the department in the previous table. So you see it's kind of the reverse now. You don't have, well, if you put the data in, you do. Yeah, before you can put the data in for this one, you have to add the data. Notice this is what I'm trying to say. So we have 10, 20, 30, and 40. What you'll notice is that these numbers here are never not 10, 20, 30, or 40. If you try to put something that's not 10, 20, 30, or 40, there's no 40 actually, but that's okay. But if you tried to add a 50, for example, or 75, or 93, or whatever, in this column, this last column, which is the foreign key, right? Depno, then it wouldn't work because of referential integrity. So there's two directions to that. If you try to delete something from the one side of the table that has a reference down here, you can't do it. And if you try to add something here that doesn't have a reference in the one side of the table, again, this is the many side down here, then you can't do it because of referential integrity constraints. Because you could actually, if you left this out, it would work. If you didn't define this, it's possible to do that in a database. You shouldn't if you have your primary keys and stuff defined, because referential integrity is a good thing. That constraint's a good thing. In most scenarios, I can't think of scenarios where it isn't. I'm sure there probably is some edge case in the universe, but in general, it's a good thing that you have these referential integrity constraints, because your data is more, you're adding things that actually exist in the other table. If you have this constraint. But if you could leave this out and put whatever you want here. That's what I'm trying to say. It's not something that's like built into tables. So it doesn't know that this is a foreign key until you tell it it is. And then once you do, then you have for referential integrity. All right. That might seem obvious, but whatever. And you create some more tables here. You can see, and this one has quite a bit of data, because it has more columns kind of spread out. And this is the sequence where you increment by one. So that's kind of like the automatic primary key where you don't have to specify the primary key. If you notice, cust.id here, these are actually defined. I think it's that. So let's count them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It looks like it's defined already, but if it weren't, what it's saying is that, I guess, because the sequence was created after this is starting data. So if you add customers after this, and there's a particular style to the insert for doing the auto increment sequence thing, and we're not going to talk about it right now, but anyway, it's setting that up for the future is what it's doing. And then you have a commit at the end. Why do you have a commit? Because you have some DML statements, like these inserts mainly. All the inserts really. The DDL, the create tables, are auto commit. As soon as you create the table, it's actually saved in the database. But these inserts aren't necessarily. And the Oracle has specific rules about when things are committed automatically or not. That might vary a little bit from one, but just in general, just inserts, deletes, delete froms, update, set, that kind of stuff. Those are typically DML statements that need to be committed to be sure that they stay permanent in the database. So that covers the demo tables. And again, I'm not sure. I don't remember exactly why. I need to revise this lab probably and make sure it all makes sense, because it's not my lab. So part 2 was where we ran into a little bit of trouble, and it was because you have, how long is this video so far? I don't have the time showing, but I think all this works. And you guys can answer these questions. I kind of given the answer earlier about these. But the main thing is, I'm trying to get to it here, problem solving task. So it's this one. So in the problems, this is where the confusing part. Let me talk about this first. The first part of it, problem solving task. So number 19 is where people have questions, and it's good for you to have questions. I mean, it's appropriate for you to have questions because it is a little bit confusing. But it says in the problem section of chapter 7, and if you ignore the pages, I don't know if the pages have changed since then. If you had the physical textbook, it would be page 323. So that might be something I need to check. But this is the specific part that's causing confusion, I think. So the problem section, what that means is, let's see if I still have it up and didn't lose it somehow. I probably did. No, there's my tab. Notice it's figure P7.1. It's not figure 7.1. If you go way back in the actual reading of chapter 7, there is a figure 7.1 that doesn't look like this. This is like at the end of the chapter, you have some problems you work on, and those problems also have figures, and that's why they're labeled P7, problem 7, figure problem 7.1. And these are the databases that are referred to. Let's see if I can pop this out and make it look better. Is that how you do it? View enlarged image. Is it actually enlarged? It looks smaller to me. Because that's, I don't know about you guys, but that's kind of blurry to me. Anyway. This is the job table, by the way. This is the one that we, in quotes, did in class. So I'll talk about that in a second. But I think this is IMP1. Or they talk about IMP1 later on. But it's in this section. That's the main thing. So subsession, total of hours, all employees. It's just a problem that you have to solve. But this is the thing you do in the lab is if you were doing the problem in the textbook, this is all about giving you the information about the problem you're solving in the textbook. But you're not doing that. You're just using these tables to do the exercise that we have in the lab. So let's look and see what it says to be sure about this. So authors describe construction, read about the database. In this step, we will create a copy of the employee table. So you make a copy of this employee table, which is, and I thought about guiding you through this, but I want you to do it on your own because you can use all those examples that we just went over as a guide to doing this. You do everything the same way. You might have a little bit of variation. It doesn't have to be perfect, but as long as you create an employee table called imp1, so you're making a copy of this table and you're calling it imp_1, that it has all these things. So things that you might vary on is like what data type you use for the job code, the employee initial, how you handle that. There might be different data types. How you do imp years, maybe. Imp years is something to consider too. Why do they have imp? It seems like that should be a derived attribute, but whatever. Anyway, it can vary a little bit, but just make sure you have a created table that's called imp1. It has these columns. 1, 2, 3, 4, 5, 6, 7. But here's the reason why the job thing is brought up. See, job code. This should be a foreign key that references this job table. So you see how you have 502? 502 is database designer, and 501 is systems analysis, and then 500 is programmer, and so on. That's why the job table was referred to, and it's because we did this in class last semester. I'm pretty sure I showed them how to create the job table in class. So you guys didn't get the benefit of that, and for that reason, I will give you the job table. So here it is, drop table job, in case you've already done it somehow. I mean, I had to do it because I already did it. So, but this is what I also had to do. Let me show you. I had to do this first because I had created the imp1, not drop imp1, but drop table imp1. I'm not going to give you this script with imp1 because I don't want you to undo the work you've already done if you did somehow already do it. This is being given to you with the assumption in this script that you haven't done the imp1 table yet. If you have, I don't know, maybe just send me an email and say you don't want to redo the work. I don't blame you really if you've already done imp1 without job. But the reason is because you do have a referential integrity problem here. You have to drop this table first because it references things in here. So you have to get rid of all the references to 501, 500, 502, all those jobs. Where is it? This is the job table. It's the imp1 table. You have to get rid of all those records first before you can delete the drop the job table. So that I had to do it in that order because I already have this, and I figured I could recreate it if I needed to. So my script had that in it, and I deleted it to give this to you. I don't think you guys should have drop. As a matter of fact, you probably shouldn't have job either because we haven't done it right. That's the whole point, that you didn't have this. But assuming that you did have it, it would drop it and then recreate and add all the data. I'll be honest. I auto-generated this and then tweaked it to make it look less weird for you guys. So I'm gonna do this live. I want to test it live because I tested it in my account. I want to test it in my fake student account, which is what I do sometimes. Here's a student account. So this is just to make sure that it will work. So drop table actually should give this student an error, but that's okay. It'll just go past it, and then it should do everything else. So no, that didn't work. I guess it's because I already. Maybe I did. Did I already have that? Okay, this is a pause. This is why I'm testing live. That's why I shouldn't test live. Oh, so scatterbrain. So yeah, I'd done this in the actual workspace, but I forgot to copy it back to the script. So it's good that I checked because I would have given you something that might not have worked. So yeah, the thing that I had that auto-generated left some of the semicolons out, which are needed, ironically, even though automatically generated. So you have to have semicolons at the end of each one. If you do it in a script, each one of these statements needs to have a semicolon. Proper SQL has a semicolon at the end, including this one. It probably won't matter because it's the last one, but so when you copy all this, no, actually, so this is all worked actually, but now that I have one, I shouldn't get any. You see how I have this error? I have this error because I'm trying to drop a table that doesn't exist, but now it does exist, so you can see what happens when I run this script. Everything seems to work. So yeah, let me do this one more time. I thought I deleted all that, but I guess not. There shouldn't be any errors in the output now. Yeah, so drop the table job. So it gives you, an output. It tells you what happened. So I dropped the job table, created the job table, inserted all the data in it, committed all, all the DML, the insert statements, and then altered the table. This is another way you can do it. After you create a table, you can go back later and alter the table. This is also DDL, data definition language. I'm altering the table to add a primary key that it didn't already have, and this is done separately from the create statement. So you can usually fold the primary key statement into the create table. Like at the moment you create it, it's going to be the primary key, so you go ahead and do it that way. But alternatively, you can, after the fact, change the create table with alter to add the primary key. Literally add in the syntax here, right? So what was I going to say about that? Oh yeah, it was auto-generated, and that's how the generated thing did it. So I just kept it instead of adding it up here. But regardless, you get a couple different views of this that way. One other thing I want to talk about the inserts before I finish this, and I'm going to upload this and make an announcement so you guys know about the little tweaks to this assignment. The insert, there's a couple of different styles of insert. So one of them is this. So you insert into the table name. So insert into job, and then you have parentheses, and you list the columns. Just the names of the columns. So if you go back up to the create table, you can see these are the things we named these columns: job code, job description, job charge for per hour is what that means, job last update. So you see it has the exact table columns here. So you list all those, and then you have this keyword values, and then you have another set of parentheses that has the data. This is the data, right? This whole class is about data and databases. This is the actual data. So this is the value 500 that matches this first column. So they match, first column, second column is the second thing here, third is the third, and then fourth is the fourth. So that's how that works. Don't worry about the to date. I was just looking at that. This is just making sure it's a date and it's saying the date format, and it's just advanced SQL. You don't have to know. You could just put this in right here, and it should work, I think, because that's the default date format anyway. But anyway, don't worry about the to date stuff. But that's how that works. The other variety is if you're going to give data for every column in the database, you can do this. You can leave this out and just list the values, and you don't have to match it up. It depends on, so when I was talking about the auto increment thing with the sequence, that's the case where you would leave out I think you would leave out the job code, and so I think if you have the auto commit, you have to list the columns. It all depends on whether things can be null or not too. Like if you have some if you have like 3 things that don't have to be null, you can list those, just those. Let's see, you can leave out the things that don't have to be null and include the things that have to be null. You have a subset, in other words. I should probably show different varieties, but I'm just telling you that you'll see varieties of insert intos depending on whether things are null or not, or whether you have sequence, auto increment kind of stuff. But this is kind of like the complete way to do it, the standard full way to do it. So you're always okay if you use that. So the last thing I'm going to say is that, so the script you just saw that I tested, I'm going to upload this, and you can use this to create the job table before you create the imp1 table. If you haven't done it yet, if you already created the imp1 table, you might have trouble if you do if you have a foreign key in your imp1 table. I feel like a lot of people who did create imp1 probably don't have because they don't have the job table, right? So it shouldn't be a problem. You can go back and add the foreign key after you've inserted all the data. Actually, that constraint, just make sure all the references match from the foreign key in the imp1 table to the job table. Make sure all of those numbers exist in the job table that you've added, and then you can look up how to alter and add a foreign key to your imp1 table that references the job table. That's the whole point of the. Frankly speaking, if you left the whole job thing out and just did the imp1, you should probably be okay too. But it makes more sense to have the job table, so you can reference those values, 500, 501, 502, for the job code in your imp1 table you create. So that's the whole point of that. Does that cover everything? So again, I'll put this up in Brightspace, and I'll tell you where it is. I'll probably just add that new script, like in where the create table script is for SQL Lab 1. And yeah, just describe imp1 after you've done. So yeah, really just step 19 without the job thing. Honestly, you could leave it out and just do the imp1 table and describe imp1, because that's really all I'm looking at. I think that should cover it, like the questions that people had. So if you have any more questions, send me an email. That's the best way. Make sure you send me an email. Don't send me a Brightspace message. I get them, and it's easier to respond more quickly if you send an actual just student email instead of a Brightspace message. All right, I think that should cover it, and talk to you later in class. How do I end this? Every time I forget how to end it.